Hey, welcome back everyone. We've been talking about immutable and mutable, and in this video we're going to get a better sense of what this means by looking at or trying to understand how Python stores values in memory. Each value has a memory address, or each variable has a memory address. So we're going to look at that in this video. And I want to start off by pointing out something that we did not mention last time, and that was that the variable type int is also immutable. And so what I'm going to do is define a variable, we'll call it spam, and we'll set spam equal to 100 right now. So you can see that in my variable explorer I have spam, it's of type int, and it has the value 100. Now, what Python does, or in any programming language does, is it's really referencing the address, the memory address of this variable spam, and we can look at the memory address of spam by using the ID function. So I type ID and you see it lights up. It's a function, and I'm going to send that function the variable spam, and it returns this weird number. And you're going to get a different weird number if you do this. Every time you call it, every time you do this, if you close Python and you open it back up, you're going to get potentially a different number. And that's because depending on how your computer is running, you have different availabilities in different memory locations. And this number is the memory address of spam right now. Okay, now if I define some other variable, let's say bacon, and I set it equal to spam, now you'll see my variable explorer. I've got the variable bacon, and it is of type int, of course, and it also equals 100. Again, that's unsurprising. If I look at the ID of bacon, and remember this is the memory location of bacon, you see that, and you'll get the same takeaway. The same takeaway is that bacon and spam have the same memory location. And this is the idea of reference. Python is referencing the memory location when you set this assignment statement. So you're really technically not assigning the value of spam to bacon. What you're doing is you're setting the memory address of bacon equal to that of spam. So they have the same memory address now. And now if I change the value of spam, like if I set it equal to 13, okay, because an int type int is immutable, I cannot change that value in that same memory location. Now I have changed the value of spam to 13. You can see that in my variable explorer, but to do that required Python or the computer to take spam, move it to a different memory location, and then write it as 13 instead of 100. And we can see this by looking at the memory location of spam now. And you see the memory location has changed. That's because, again, an int type is immutable. So if I'm going to overwrite spam, I have to get a whole new memory location. Now, bacon, which we said was equal to spam, well, we didn't do anything with bacon. So if we check bacon's memory location again, you see it's still the original one. And so hanging out at that original memory location is the value 100. And so we can see that just by typing bacon, and we see that bacon is unsurprisingly still 100. Right? That's because, again, in that memory location, we have the value 100, and bacon is referencing that memory location. And again, once we change the value of spam from 100 to 13, we change spam's memory location because int is immutable. Now, that should none of this should be surprising at this point. Yeah, maybe you don't understand exactly the memory locations, but the fact that we changed spam from 100 to 13 and bacon was left unchanged, no, that should not be surprising. Now, I'm going to do a similar experiment but it's going to have a totally different outcome. I'm going to clear all this and reset the variables. All right, now let's define a list which is mutable. And I'm going to define my list to be spam, and we'll just keep it simple for this demonstration. How about the integers 0 through 4? Okay, so I hit enter and you'll see that spam is in my variable explorer. It's in memory. It's of type list, which is mutable. Now I can look at its memory location. It has a different one now, of course, right? And I'm going to set bacon this time equal to spam, and I'll hit enter, and now bacon is in memory, and it's of course a list type, and it has the same list, the same items. And I'll look at the memory location of bacon, and I see that it is the same. Again, your numbers will not be the same as my numbers, but your takeaway is the same, is that what has happened by the assignment statement is that we assign the same reference, memory location reference from bacon as we did spam. So they're pointing to the same location in memory, thus they have the same contents, right? Value. Now, because spam is mutable, because a list is mutable, if I say spam, let's just change it. I can change the 0th element, for example, and I'm going to just write hello. All right, so let's look at spam. Of course, now spam is hello 1 2 3 4, and because spam is mutable, we can change the value in place, or right in that memory location. So if I look at spam's memory location now, it still has the same one. The computer did not have to move spam to a different memory location, again because it's mutable. But remember, here's the surprising part, remember that bacon is also pointing or referencing that same location in memory, right? Bacon has this memory address, just like spam has this memory address. So here's the surprising part. Even though we did not change bacon, because it points to the same place in memory, you see bacon has hello too. And this you need to be aware of. This is the source of a lot of bugs in student programs, and this bug is hard to catch. And you can just remind yourself, or just be vigilant that that lists are mutable, so they are edited or overwritten right in the same memory location, and strings and tuples and ints are immutable, and so they if you want to edit them or overwrite them, they get moved to a different location in memory. All right, so thank you very much. I hope that made sense, and I'll see you in the next video.